One of the most important things you need to be able to do with polynomials is factor them. And in this video, we'll be looking at how to factor based on the number of terms that are in the polynomial. These are the steps we're going to follow. The first thing you always do is look for the GCF. Once you have found the GCF, then you look at the number of terms that are left. If there are 2 terms left, you're going to factor using special cases. If there are 3 terms left, we're going to use something called the AC method. And if there are 4 terms, you're going to factor by grouping. So let's consider first the GCF. Anytime you begin factoring, the first thing you want to do is to look for that greatest common factor. So for example, in something like this, we see that all of the terms can be divided by 4, and all the terms can be divided by x squared. When we factor that out, you can think of that as division. So I'm going to divide each of the remaining terms by 4x squared, which is what I pulled out, which leaves me with 3x to the third. Remember, we subtract our exponents, minus 1 minus 2xz cubed. And the nice thing about factoring is then we can check it because I can simply FOIL and I get 12x to the 5th minus 4x squared minus 8x cubed z cubed, which is what I started with. So this is the factored form. After you begin looking for that GCF, if there's not a GCF or after you have found it, then you look at the number of terms that are left. If there are 2 terms left in the remaining terms, you're going to factor using these special binomials. I've listed them here for you. There's difference of squares. Notice in each of these, there's only 2 terms, difference of cubes, and then the sum of cubes. The patterns are very similar here between difference of cubes and sum of cubes, and sometimes it can get confusing where the plus and minus signs go. A student one time shared with me to remember SOAP. So for difference of cubes and sum of cubes, remember that the first sign is always the same. So notice this is a minus, this is a minus, this is a plus, this is a plus. So it's the same as what you started with. The second sign is always the opposite, plus here, minus here. And then the last sign is always positive. If you're factoring and you end up with 2 terms left, so for example, something like 27 a to the 6th b to the 12th plus c cubed. There's only 2 terms, so we know it's going to be a special pattern. We've already checked for a GCF and there's not one. So now we take each of these terms and it's a cube. So we're going to take the cube root of each one, and that's going to give us our a value, which in this case is going to be 3a squared b to the 4th. Remember, to take the cube root, you're going to divide the exponents by the root outside. And then for this second term, we're going to get our b value, and our b value is going to be the cube root of c cubed, which is just c. And now we follow this pattern for the sum of cubes. To factor it, it's going to be a cubed. A for this first term, which is just 3a squared b to the 4th, plus, same sign as what we started with, b, which is just plus c, times a squared. So we're going to square this whole thing, which gives us 9a to the 4th, b to the 8th, minus, again, opposite of the original sign, AB, which is going to be 3a squared b to the 4th. And then last, always positive, plus b squared, which in this case is c squared. So that's our factoring by special patterns. There's 2 terms, we factor by special patterns. If there are 3 terms, we use something called factoring using the AC method. Now, you may have learned factoring using the box method or something called tic-tac-toe. If you have a method of factoring that you prefer, you are welcome to use that. This is just a pattern that I have found that seems to help students organize their thoughts. If we have 3 terms in what we're trying to factor, then we think of these as our coefficients are a, b, and C. And remember, it's our coefficients, not the variables. And so you're going to first of all multiply A times C, which is going to give us negative 15. And then our goal is to factor what we just multiplied and find what adds up to B. So if I list the factors of 15, they are 1 and 15 and 3 and 5. I can combine 3 and 5 as negative 3 plus 5 to get that B term. And then I'm going to rewrite the expression. So this is going to become x squared plus 2x minus 15. I'm going to rewrite it, splitting this term into those factors we just found. So it'll be x squared minus 3x plus 5x minus 15. This is the part that folks seem to forget most often, is splitting that term. So we have multiplied AC, we factored AC, we've rewritten the expression, and now notice we have 4 terms, and this leads us to our last method of factoring, which is factoring by grouping. When you have 4 terms to factor by grouping, you split it in half and then find the GCF in each part. The GCF in this first part is x, so I'm going to pull out x from both pieces and I get x minus 3. The GCF here is 5, and so that leaves me with plus 5 times x minus 3. And notice these are the same. Those should always end up the same. Because they're the same, that's now a GCF. And so I'm going to pull that out of both terms. And that leaves me with my other factor of x plus 5. So 4 methods to look at when factoring. Always look for the GCF. If there's 2 terms remaining, you're going to use special patterns. If there's 3 terms, you're going to factor using the AC method or a method of your choosing. And if there are 4 terms, you will factor by grouping.